Alrighty. A ball is thrown vertically upwards at a speed of 44.1 meters per second. Calculate the time interval between the instance that the ball is 39.2 meters above the point of projection. So, what happens is it goes up, it hits the 39.2 mark once, then it hits the 40, it hits its maximum height, more than likely. I don't know what the maximum height is. Then it comes back down again, and it once again hits the 32.32, 39.2 again. Now, what do both points have in common? Same displacement, which means the same S value. Okay? Once again, I hit the point home the other day that S is not distance, it's displacement. Okay? And our U value is 44.1. Our V value is, we don't know. Our A value is minus gravity, which will be minus 9.8. And then our T value is very simply T. Now we're after the T values. Okay? So we're not going to use V. So what formula do you think you're going to use? Yeah, ut plus a half at squared all day long. It's nearly always ut plus a half at squared. And 39.2 equals 44.1. T. Gravity's working against us, so a half of minus 9.8. We get us minus 4.9 t squared. Lob it all into one side. T and then plus 39.2. Are they all divisible by 4.9? Imagine, are they? 8, yeah, 8 times the last one. So t squared plus 8, and then this one is minus 9. Alright, look, you're in business here. T minus 1 and minus 8. Both positive answers, which means both acceptable answers. T equals 1 was the time when it went past 39.2 on the way up. On the way down, it passes at t equals 8. Will I get full marks for my two answers there? Why not? Time interval between. So what is the actual answer then? 7 seconds, okay? Now, that's as easy as it gets for a part A and leaving cert questions. That's as easy as it gets. There's only worth 20. If they're that nice on part A, it means lurking behind it is something like this. Okay? Enjoy! Have a look at this. A lift ascends from rest, U equals 0. Constant acceleration F. V. V equals V. It continues for this speed for t1 seconds, and then decelerates uniformly to rest with deceleration F. The total distance is d, and the total time taken is t. Acceleration and deceleration are the same. What does that mean about their time intervals? Exactly. So there's a bit of a give me there, right? So we do, you accelerate, you reach v, you stay there for time t1, then you decelerate at the same rate. So that means that those two triangles are congruent, as in they're identical. A and B are the same. Okay? Same height, same length of time. Now, it might be handy for us to convert them into general terms using t. So, if I was to say x, the two of these time frames are x, okay? I then say t1 plus x equals what? Total time, which would be t. And I get 2x equals t minus t1. And then what can I say about x? T minus t1 all over 2. Is that right? So what can I do down here then? Just replace them with t minus t1 over 2. Now, if If the math is really tricky, you can always just store them as x until the very end, and then just replace it back in again. Do you get what I'm saying? You can use x as a placeholder variable. All right, done. Show that v equals a half ft minus t1. Okay, should be easy enough. I'm going to use a different letter today. I'll call it a. Tan a. What's tan a the same as? The acceleration. So tan a equals f, and f in turn will equal. What does f equal? I'm going to say v over x for a second, just because I'm lazy and I don't want to write out that lots of times. So what's the next thing I'm going to say? v equals fx, and now and only now am I going to replace in that x value now. Okay, didn't want to have to write that out lots of times. So f equals t minus t1 over 2, and lo and behold, that's your v value there. v equals a half f, brought the 2 to the front, then t minus t1. Everybody cool with that? We are on 15 out of 30 marks. So in your Leaving Cert, to get to this stage, you'll be on 70% of the first question, A and B inclusive. But you're on 50% of the second question. Now, next question is this here. You might as well be asked for the mass of Pluto or something like that. I don't know. It's so random. I haven't got a clue. How do you even make that happen? Okay. Take a letter that you haven't explored yet. Which letter have we not used at all yet? D hasn't been in any of our calculations yet. Which letter is it missing? V. Use the D equation and then substitute for V. That's your logic right there. It's missing V and there's a D. So that's the give. So can anybody tell me? I just gotta tidy up a bit of this now, okay? Because I need space. Alright, just gonna move this up here, out of the way. Review up here, out of the way. Alright. Anybody, what is D? Triangle plus rectangle plus triangle. Have we killed that? Now, do you know what I'm going to use? I'm going to use X. Why am I going to use X for? Well, it's going to be really long and painful otherwise, so I'm going to store it as X until I have a chance to get rid of the X, okay? So what's the area of the first one? A half BX will do me nicely. Area of the rectangle? PT1, yeah? Area of the second one? Also a half BX. Now it's BX plus PT1. Now, unfortunately, I'm at the stage where I have to sub out. Actually, I'll just sub out the V first. Yeah, we're at that stage. We're going to have to sub out the V and the X right now, okay? So let's do it. This is where things go crazy. So, just pure algebra from here, yes?
I don't think D is all.
Oh, D is just the middle part.
Just the first thing.
No, you don't decelerate. So, ascension would mean this, okay? I go up, for argument's sake, I'm going up with, let's say 10 meters per second. I stay at 10 meters per second, I decelerate, and then I stop. It never says I go back down again, but it's good that you're looking at the language tightly. Okay? So it's still just the one distance. Is that okay? It was a good idea to check that out, to be honest. Now, dx is going to be, oh dear, alright, a half f t minus t1, that's the v part. Now the x part is, yeah, it's going to be great. T minus t1 all over 2. Sorry guys, did I mess up there? No, I didn't. That's plus vx, isn't it? And VT1 is going to be VT1. So half F T minus T1, then another T1 behind that again. The variable you're looking to isolate is you want T1 on its own. So T1 on its own is where you're going for. Okay. So multiply it all out. Oh God. Alright. Half times a half is a quarter F. Then I'm going to multiply the T minus T1 by the other T minus T1 to get T squared minus 2 T T1 plus T1 2B squared. The next part after that is going to be a half F. It's going to be half F. It's going to be T1 minus T1 squared. So it's a half F multiplied by the two of them. So it's a half F T1 and minus a half F T1 squared. Oh God, my eyes hurt. Now, and the D is still over there, having a great time away from this mess. Alright, I'm going to multiply out the quarter here. So it's a quarter ft squared. Lucky for me, that's minus a half ft t1 plus a quarter ft1 squared plus a half ft t1 minus a half ft squared. Alright, something better cancel, otherwise I'm going to retire. Here we go. And oh, alright. What's a quarter? Take away a half. So identify the ones that are the same. This green one here is the same as this green one here. They're the same. Oh no, they're not the same. This one's the same. You good with that? So it's a quarter minus a half. What is a quarter minus a half usually? Yeah, it's going to be minus a quarter, whatever that is. So it's going to be minus a quarter f t1 squared equals d. Now, nobody likes fractions, so what we're going to do? For top and bottom. Okay with you? Now, we're going to get 4d. Is the 4d a good thing or a bad thing? Ah, it's a good thing. 4d is a very good thing. Now, I'm going to actually move that one to the left and the 4d to the right, as it turns out. So I'm going to get, and remember the 4's no longer exists. So it's going to be f t1 squared equals ft squared minus 4d. Then divide both sides by f, so you get t1 to be squared equals t squared minus 4d over f. Square root both sides, and you get this. That what I'm looking for? Yep. Oh, good.